Thanks, Evan.
Thank you very much. I'm Evan Ackerman. This is Jamie Moe. Let's just get started. Can you... Sorry.
Maybe start over.
Okay. Anybody? Nope, no mics. Okay. Well, can you just explain what GE Transportation is? If you're where you folks do? How about
3 and 4.
Okay.
3 and 4.
Quick fix.
There we go.
All right, how about now? Okay, great. So Jamie, can you just give us some context? What is GE Transportation and what do you folks do over there and why is it so exciting right now?
Sure. So GE Transportation is one of the divisions of GE, and it's really one of GE's most iconic businesses. You know, it's been around for more than 100 years. It's really locomotives, mining, services, and digital. And I think what we're really excited about is really how sensors, data, AI, and other things are really starting to transform the transportation industry itself.
And so you were CIO of GE just in general, and then you transitioned to CEO of GE Transportation. Can you talk about what that was like and kind of how you had to shift your mindset there?
Sure. So, so when I was CIO of GE, you know, 4 or 5 years ago, we were really leading the transformation inside GE to things like cloud computing. We really, you know, sort of built and launched the digital industrial vision that is defining GE today. And you know, it's interesting because as CIO, we were driving that transformation inside the company. When you think about our factories and this idea of, you know, no unplanned downtime, you know, inside the company, what did that really mean and how did we really do it? You know, but as I've come into transportation, it's really how to think about transforming an entire industry around the same concepts. And, you know, you start to think about this idea of whether it's no unplanned downtime or how do you really take data off of assets and transform how you work. You know, you think about a locomotive, you know, the locomotives we produce today have about 200 sensors. They pull data off those locomotives constantly, and you know, we've got onboard computing that is constantly monitoring not only the health of the engine, how those components are running, but it monitors track grade and condition, it monitors the weather, it monitors, you know, all the elements of things that run around the train. So, you know, what it's really enabled us to do is establish this vision about, you know, how transportation in the freight industry can be fundamentally rethought around, you know, how you use the locomotives differently, how you can monitor and run trains in a different way, and more importantly, when you think about the rail network itself, you know, how do you really get more trains running at a higher speed, you know, to be safe, reliable, and predictable in ways that they can't today?
So I would imagine that a lot of this sensing that you're now able to do comes from, you know, this mobile and IoT infrastructure that's growing up. So what kinds of data are you able to collect now that you weren't before? And then how does that translate into tangible improvements in the rail sector?
Yeah, so we've been monitoring our locomotives for about 15 years now. So this is not a new science, you know, inside GE. But I think what has changed is we're able to get more data, more of it, more kinds of it, and we're able to, you know, combine it and fuse it in ways that we never have been able to before with all kinds of other data in the environment. So, you know, take a locomotive. You know, when we pull that data off in real time, we're constantly monitoring it. So we monitor, you know, today 17,000 locomotives around the world in 23 countries, you know, from one location in the US. And when we monitor it, you constantly learn more about how that locomotive runs. So you're constantly tuning the performance. You're also able to predict, you know, when something may fail or when something needs to be maintained, or equally importantly, when it comes in for routine maintenance, we tell our customers not only exactly what needs to be repaired, we also give them the work scopes for that, and we can be a lot smarter about making sure that, you know, all the real-time delivery of the parts required to do it can happen just in time. So it's sort of a top-to-bottom sort of transformation of how the work happens in a much smarter way.
And are there examples that you can give of, like, this has actually made a huge difference for people?
Sure. So, you know, one of our customers, CSX, we've actually implemented something we call smart shopping in one of their service shops. And take that exact example I was just talking about, you know, it's really reduced their dwell time by about 50%. And dwell is really important in the rail industry because it's the amount of time an asset sits idle. while it may be pulled offline for maintenance. So that's, I think, a great example there. But when you take a step back and look beyond just, so that asset, and you start to look at, the rail network generally. So, railroads have, thousands of miles of fixed investment in track. And so this idea that if you know where these assets are and what cargo sits on them and when it's supposed to get to its destination, and if you could take your knowledge about the environment and where those trains are and combine it with your knowledge about the train itself, you're able to put software and AI around that to really improve the velocity in your entire network. So we have products like Movement Planner, Yard Planner that actually do those kinds of things, and we've got railroads running on that today.
And this is true not for just railroads, right? You folks work with all kinds of transport solutions, and I know that you're doing a pilot project with the Port of Los Angeles, right, that's implementing a lot of this stuff in kind of a much broader way. So how's that going? Yeah,
the Port of Los Angeles project is actually super exciting. When you think about cargo, 90% of the world's cargo hits, a seagoing or an ocean vessel at some point in its life. And so you think about seaports, they're an incredibly important and vital part of really a freight transport ecosystem. And they're interesting because they're really typically capacity constrained. They have a stretch of land that typically can't be expanded. They've got a certain set of assets and rhythms that surround it. You think about chassis operators, you think about terminal operators, you think about railroads who have to schedule trains, trucks that have to schedule trucks coming out of a seaport. Well, today, when an ocean vessel hits port, and let's take the Port of Los Angeles as an example, typically a port won't know what's coming into port, the vessel and what's on it and where it's going, until about 2 days in advance of hitting port. So you think about their ability to really plan, and all the railroad, the chassis operator, all of the suppliers' ability to plan kind of how much load will I get, where is it going, how do I plan, how much equipment is needed to actually transfer it. It's a very inefficient process today. So we're working with the Port of LA on a pilot project right now that's really going to expose and automate all of that data in ways that wasn't able to be done before. And so we're going to be able to take that data in 2 to 3 weeks in advance of a ship coming in, expose that to the partners, which is going to enable just a reduction in dwell time, the ability to have the right equipment on site when you need it. And so if you think about if you had 100 chassis when you only needed 80, you can redeploy those assets in other places. And so we're seeing some really exciting results as we launch the pilot right now. But it is all about reducing dwell time, leveraging assets in a different way, having just a much different turnaround time and experience, and much greater efficiency in terms of truckers, railroaders, ports, terminals, all the people that participate in the process.
So if I have a company that is not, that doesn't have a nationwide rail network and doesn't have a port, a much smaller company, are there lessons that I could learn from what you folks have gone through?
Absolutely. I think whether we're in transportation or in my role as GE CIO, we work with startups all the time, and we work with small companies all the time. And, I think there's one thing we keep in front of us all the time, which is as we go through this sort of transformation into just the next generation of what it means to be an industrial, I think it's important to know that you really can't do it all yourself. You need partners. And I think that goes for big companies, and I think that goes for small companies. And I think it is really important for any company to deeply understand what expertise they have, what domain they deeply have, and where they need a deep partner to help them both create and ideate, but really transform together forward. We used to laugh when I was the CIO, because we used to keep this big roadmap of exactly where we were looking to see transformative technology, how and where we wanted to really push the envelope. And we worked with a lot of startups, and it was great because on one hand, we could really work with them to shape their vision, and they could move a lot faster than we could, and great partnerships. On the other hand, I used to joke with them and say, be careful what you wish for, because, sometimes we can also love you so much that we break you. But I think the point is that you've got to find the spaces where you can both go fast and go slow, and you got to know when to do it, which way, and you got to know what you're good at.
Are there near-term technical advances that you folks are looking towards that you think are going to transform the industry either a little bit or a lot over the next, say, 5 to 10 years?
Look, I think like any industry, transformation in freight transportation tends to be generational. And so I think, right now it's all about how do you have, we have a GoLink platform which we put on a locomotive, which we call the brain of the train, right? It is the mobile data center which pulls the data, it processes data on the edge, it sends controls back to the locomotive. Companies are really, I think, putting in front of them what does being a digital railroad really mean. And this idea that it's about getting more out of your CapEx, it's really leveraging your OpEx in different ways, and getting those trains to be more reliable, predictive, is really the vision that's in front of them. So when you think about near-term technologies, it's not only the hardware, but it's also cloud computing, it's edge computing, and the ability to intersect with big machines in ways that nobody's been able to do before. It's that intersection of sort of the physical and the digital that I think is really the sweet spot right now.
Well, how do you think that autonomy is going to affect both the kind of rail and otherwise? Because whether you look at it from the perspective of autonomous trucks may take over to some extent from the rail industry, or whether autonomy makes its way into the rail industry, how's that gonna look?
Look, I think freight and rail have important places in freight transport, actually trucking and rail. But rail is a very, very cost-effective solution for the industry. And when you start to think about autonomous, I think everybody talks about cars, they talk about trucks, and it's something that we all read articles about it in the paper every single day. When you start to look at the rail space, we have autonomous trains today. Start to think about airport transit. You start to think about monorail systems at places like Disney World, right? You already have autonomous trains occurring today and live today, but they tend to be in closed loop environments. You also have them in open environments in Europe and passenger transport and other spaces. If you take a step back though and you start to think about freight rail transit, it's kind of interesting because a freight locomotive can be 2 to 3 miles long, right? It can be carrying 10,000 to 20,000 tons of cargo. A locomotive by itself is a 400,000 pound machine. So think about a machine like that carrying that kind of cargo going along the track at 30, 40, 50 miles an hour, right? It can take up to a mile or two of distance just to slow and stop a train. So when you think about knowing what's in the environment, whether it's a car stuck on the tracks, whether it's debris, whether it's a break in the track, or whether it's some other unforeseen obstacle, when you think about spacing of trains, there's all kinds of different elements that come into play when you start to think about doing something at scale with freight. And I think there's an economic and a regulatory equation too, but the technology is there and it is transforming over time. You just don't hear it talked about quite as much as you do cars.
We do hear a lot about autonomous freight in the context of trucks. There are lots of companies working on that, and there are still regulatory and technological issues, but it really seems like within the next 5 years, that's going to be a big market. How is that is that something that GE is preparing for to kind of integrate that?
Look, I think that's one of the reasons why the concept of the digital railroad is so important, because when you can run more trains with higher speed, more predictably, and really predict the maintenance around the assets so you have no downtime, that's really a way to get more throughput on the same network and compete in different ways. And so while the vision today may be quite different than the vision in 5 and 10 years, because I think it will evolve, and I think this idea of autonomy is going to continue to be very front and center, I think that both freight, whether it's trucking or trains, you're going to see a lot of automation that happens along the way.
So more generally expanding just beyond actual moving of goods, when we talk about autonomy in the context of things like factories and just throughout the workforce overall, how is that going to affect factories in the future or the workforce in the future?
So what you see in factories, factories tend to be very generationally changing sorts of things, right? These are capital-intensive assets that people typically put in there, and how you work that, tends to be decade-like change shifts. One of the big strategies we launched inside GE probably 3 or 4 years ago was the concept of a brilliant factory. And it was really built around this idea that if we deliver machines for our customers that really have limited unplanned downtime, why can't we do that same thing with respect to our own machines that are in our own factories? And so we set out to really build 7 showcase sites around the world, one of which is GE Transportation's site in Grove City, Pennsylvania. And look, a brilliant factory from our perspective is something that combines lean manufacturing with additive, with advanced manufacturing technologies, with digital. And so take Grove City as an example. Grove City is an engine plant that remanufactures about 1,200 medium-speed diesel engines per year. So it's a very big plant. And it used to be that when we brought these engines in for remanufacturing, so remanufacturing is basically a repair process, right? You bring it in after it's been on the line for a while, you tear the entire machine down, you remanufacture all of the components, you assemble the engine at the end of it, you deliver it back to your customer to put back onto a locomotive. That's the way it used to work. So today what happens is, because we already know the actual condition of all of the components in that locomotive before it ever hits our shop, we can, when we tear it down, have a purely condition-based remanufacturing repair scope for that engine. We know exactly what components don't need any repair, it can be set aside. We know some that need light repair versus heavy repair, and we align our remanufacturing scope to that specific scope of that engine. And so what happens is we've been able to reduce dwell time of that engine in our shop, or basically reduce cycle time by about 20% because of that. And it means our customers have that asset back in revenue production, that much faster. It also means we can drive more efficiency in our factory. So I think that's an interesting example of what it means to bring it to life. And then when you think about how jobs change, look, I think for the next at least decade, it's not about the replacement of jobs, it's about how jobs shift and how skill sets are needed in different ways. And it's about how, if you're a supply chain or a factory leader, you've got to know digital just as much as you know how to run a factory, right? If you're an engineer, you've got to understand how control systems not only control a machine, but how they intersect and use data coming from any other digital realm in ways to make that asset run better. So I think it's this melding of skill sets that's going to happen, and that's really why at GE we've launched a handful of different massive sort of open, online, collaborative, different ways to train our people, to really respond to that.
And how has it been making that transition with GE, which is such, it's an enormous organization with a very deep history, and this is a lot of change happening very quickly.
So digital industrial is sort of exactly that, right? You've got the big physical, physics and engineering of machines, and then you've got really the software side of it, AI and other things with that. And I think, look, software's not something new to GE. I think that's the good news. I mean, we've had deep software domain for the last 30 or 40 years. And in fact, that was really part of the big driver behind this transformation we're leading, because you have this realization of the past couple of decades that, software and data is becoming an increasingly important part of the hardware itself, the part of the machine. And that's really what's behind it. But, when you think about what's hard, look, I think on either side of that it's hard, right? The digital domain needs to understand the deep machine side of it, the physics, how does it work, how does it learn, how does it work in that environment, and railroad operation as an example. The other side of it is the engineers who have 30 or 40 years of deep expertise on how an aviation, an engine might run on an aircraft. They've got to sit with the digital folks and really marry that knowledge too. So what we found is today it's people working in multidisciplinary teams, and it's side-by-side work to learn and co-create together. I think in the future it'll be that skill set's all going to be in the same person.
Okay, that's awesome. Thank you so much, Jamie. This is all really exciting.
Great, thanks, Evan. Glad to be here. Okay.